Okay, I'm back after an attempted test run outside, and it will not start and run on its own. I'm going to have to go deeper. There's obviously more troubleshooting to do. I think it may have an air leak, so I'm going to take some parts off and do some port blocking and prepare for a leak down test, pressure and vacuum test. So I'm going to pause the camera. I don't want to make the video too long. So when I come back, I'll have things torn down and set up. Okay, I've done some disassembly in preparation for a pressure and vacuum test. And in removing the insulator and the heat deflector, it's clear that the gaskets were there and they were sealing. That's not the problem. But when this was exposed, very evident. There's a huge problem here. And I'm going to bring the camera in for a close-up. You can see what I found. Okay, one of the cylinder mounting screws is not even there. Okay, and then there's also a one down on the lower part. You can just barely see it. On the clutch side, you can see the head of it, and it is there, but it's out several turns. It's loose. And one of the clues is you can see that there's a lot of wetness, like the fuel. The air leak was blowing a lot of fuel, and this is all wet with wet, oily sawdust. So clearly a large air leak there. And it's a tricky air leak because when the engine is in its relaxed position, the cylinder and the crankcase are together. But when you pull the rope, you hit a compression stroke, and it's pushing the cylinder apart from the crankcase. And then if you are able to get the engine to start and run, when the engine fires, it really spreads apart and takes a gulp of air. And it will only do that when you're pulling the rope or when the engine is trying to run. And so that's a little bit of a tricky air leak. It's not so obvious if you were just to pressure and vacuum test it like this. The engine's actually trying to blow itself into two pieces. And so I've clearly got to fix this even before I can pressure and vacuum test it. Now, I've gathered up a few plates, and this one is marked 1111 and 4205, and it is for the TS760 and the 076, and the bolt pattern it's too big. It won't fit this saw. Got a homemade plate here that's labeled 076, and same thing, the bolt pattern doesn't match. And this one was made out of a lawnmower blade, and sometimes when you don't have the factory block off plates, and you can take an old chainsaw bar or an old lawnmower blade and cut it up and drill some holes in it, and as long as you've got an old inner tube and a pair of scissors, you can cut rubber out of an old inner tube and make sealing plates and block off plates homemade. But this one here, this one is also labeled 1111, and I think this one's going to work. If this was for the 041, it would say 1110. And so I'm thinking that since it says 1111, it's going to fit up here and work for me. So I'm going to, I don't want to make the video longer than necessary. I'm going to do some nuts and bolts and replace the cylinder base gasket, tear the motor down, and get that big leak fixed first before I mount the block off plates and give it a real test. It would be a waste of time to pressure and vacuum test it now when obviously there's a huge air leak there. So I'm going to pause the camera and we'll come back. Okay, further along in the teardown process, and you can see that about 3/4 of the cylinder base gasket, the original cylinder base gasket, are still there, but this area here, it's missing, it's blown out, and I don't see any cracks in the cylinder flange, and the cylinder looks really good, and the piston looks really good. I don't see any issues. He's lucky that it didn't seize up because of an air leak and a lean mixture. Everything's fine. And so I'm going to clean things up and get a new cylinder base gasket and bolt it all back together with Loctite, and then we're going to do some pressure and vacuum testing. Okay, I'm getting prepared to put the engine back together, and as you can see, this is what was left of the original cylinder base gasket. I've checked, and there is enough clearance to get this gasket over the piston, so I do not need to remove the piston in order to get that gasket on there. One thing I notice is this connecting rod, it's very early style. It's a split rod and is held together with screws. So there's a rod cap that comes off. That's pretty old school. I've never seen one like that actually. And the cylinder cleaned up pretty nice. I have an aqueous pressure washer, and I don't see any cracks in the mounting flange here, so there's no issue there. I'm going to be using this copper high temperature spray gasket on the cylinder gasket, and has to spray it on there and allow it to set and get tacky. And I'm going to be using Loctite on the cylinder mounting screws, and these are the tools necessary to put the cylinder back on. Got a support block and a ring compressor, and that allows the cylinder to go back over the rings. My assembly lube is 2-cycle oil. This is Stihl HP oil. That's all it is. I'm going to be oiling the main bearings, oiling the cylinder surface and the rings and the piston and so forth. And I'm going to put it back together quickly because I don't want any contamination to go inside the engine. I've very carefully cleaned around the cylinder crankcase mounting area, and got to button it back up quickly so that dirt won't migrate in there. So we'll come back when it's all back together. You don't need to see every second. All right, final preparation prior to vacuum and pressure testing. This will be the first time that I'm using a brand new Capri inch-pound torque wrench. I'm going to torque the cylinder mounting bolts, the ones that vibrated and fell out. And they are supposed to be, they're 5x20, 5.8 foot-pounds, which is about 50 inch-pounds. So I've got this set. a diagonal pattern. Okay, those are all torqued down. I've got a plug in the impulse line. My decompression button is not activated. My spark plug is tight. And this is the pressure and vacuum tester I like to use. It alternates between pressure and vacuum depending on where the position of this sleeve is. That's pressure, that's vacuum. You always want to test your tester prior to connecting it, because if you have a hole in the hose, you could be chasing a leak in the engine and not realize that your tester is faulty. So put your thumb over the hose first and verify that your tester is holding. And some mechanics like to vacuum test first, under the theory that if you pressure test first a double-lipped crankshaft seal, if you apply pressure to the interior of the engine, you can force the old rotten lips of a double-lipped seal against the crankshaft, and then it will artificially pass a vacuum test second if you pressure test first. I really haven't found that to be true. If the seals are bad, they're going to leak. The pressure is not going to be enough to force an old rotten seal lip to contract and then hold and artificially pass a vacuum test. So I'm not so concerned. I'm not really too sure that theory is adequate. But we've got our block off plate on here now and can connect, and the book, this is for an 051, not an 050, but I think it'll probably be adequate. It says that it's supposed to hold half a bar for about 30 seconds, and that would be considered passable. So we're going to see what happens here. And I'm having trouble even getting it up to half a bar. Yeah, it's not going to pass. I'm trying to vacuum. Yeah, it's not going to pass. So I've got air leaks to chase. And one of the things I like to do, if I get a leaker, and I don't want to have to keep pumping and spraying soapy water around the compression release or the block off plate or the crankshaft seals or other areas, cylinder base, and looking for bubbles and trying to pump and spray at the same time. I have a mini regulator, and I can set pressure I can set the pressure on this mini regulator to 1/2 bar by adjusting here, and then I can connect and then I can take my time and go around the engine and spray and see if I can locate a leak. So that's what I'm going to do. And I'm going to shut the camera off. This might be a little time consuming, and I'll bring you back when I find the leak. Okay, I have found one small leak. I'm going to bring the camera in here for a close-up. Okay, this is leaking into the interior of the oil tank. There's air coming out of the vent on the oil cap, and what that means is like there's an O-ring and a seal on the pump shaft here, and this pump shaft is in the interior of the crankcase, and so some of the pressure could be leaking past that O-ring and that seal and going inside the oil tank. So that's one leak that I've chased down. So I'm going to take the oil pump out and look at that seal and that O-ring, and hope we have to get them one at a time. I've got my constant 7 psi being supplied continuously to the engine while I'm chasing leaks. And what I've done here so far is I have replaced this O-ring, and I've applied Durco sealant to this oil pump body seal, and that's to prevent some of the pressure and vacuum is going around the pump body and entering the oil tank and escaping through the oil tank. So I've got that addressed. But the other thing I've found here, I'll bring the camera in for a close-up. I have removed the clutch because it still will not hold 7 psi for 30 seconds. And so I have used my clutch tool here and removed the clutch to expose the PTO seal. And there's two of them. There's an inner one and there's an outer one, and that's because the oiler gear turns independently. It's a part-time oiler. When the engine's idling, the worm gear to drive the oil pump does not turn. So that's why you have two seals, an inside one and an outside one. And it's definitely leaking. And get some. Yeah. Now, the outside one doesn't appear to be leaking, only the inside. However, I've got both seals in stock, and so while this is apart, I am not going to take a chance. I'm going to replace both of them. So. Let's get this out here. We've got a little bit of air pressure behind this, so it'll help push it out. And it's old and tired. Okay, I was able to get that small seal out. It was in there real tight. I'm going to put the new one in. That's going to be tight. Okay, new seal installed. Release my pressure. I don't have to fight it.
You got it?
Yep. Okay, I've chased down every air leak, and I've removed the constant supply of half a bar 7 psi from my regulator and replaced it with a fixed amount of that pressure. And I was actually interrupted, and it's been sitting here for a couple hours, and it's only dropped about 1.5 pounds, 0.4 bar. And that's really good. Now I didn't have the right size seal driver to install the larger outer seal. So I used a washer and drove the seal in flush to the crankcase with those parts. And the inner seal, it was petrified. The outer one was a little bit better, but I think what's going on here is the clutch side is the hot side of the engine, and it baked the inner seal and to a certain extent the outer seal, as opposed to the flywheel. Flywheel side is the cool side of the engine, and even though that seal is probably 55 to 60 years old, it's really holding quite well. And I don't want to pull the flywheel off and upset the points, because the ignition is working fine on the saw, and create a lot of extra work that's unnecessary. So I'm going to release the pressure, and I'm going to switch this to vacuum, and we're going to retest. Okay, so I'm going to change to vacuum, and it's supposed to hold half a bar, 7 psi for 30 seconds. And the needle's, it's barely moving. This is going to pass. Okay, so to make the video short, I'm going to do reassembly now, and I'm pretty confident that it's going to work because the single sole source of air intake is where it's supposed to be, through the carburetor only, not from bad seals, bad gaskets, bad impulse line, through an oil seal in the oil tank and so forth. Only the carburetor. So very important on a two-stroke engine. So I'm going to pause and we're going to do some reassembly and I'll come back